Here's the last example for our class kick today, and we are going to be writing the inverse of h of x equals to 5x minus 2. And we're showing this one just because there's a little bit more to this statement. So the first thing I'm going to do is I'm going to go back and rewrite that statement. Log base value equals to exponent. And in this case, we need to identify some of the parts. So it looks like y would be the value, 5 would be the base, x is the exponent, but wait a second, we have this extra. And because we have this extra, it's not really written as base exponent equals to value, where we only have this one piece equals to a value. So we need to get rid of that minus 2. So when we write the inverse of this, I'm going to start by eliminating that subtraction of 2 by adding 2 to the other side. And we should be left with y plus 2 equals to 5x. Now, the indicator that we can go to the logarithm statement is simple. Is the base alone with an exponent? And in this case, the base is 5. The exponent is x, and there's nothing else attached to that base and exponent. So we can go directly to the log statement at this point. So I'm going to write log a base of 5, a value of y plus 2, and that is equal to an exponent of x. And we've solved for x, which is the point of the inverse, which is the goal we're trying to do when we find the inverse equation. So I'm going to go ahead and rewrite it. We used h of x. I'm going to use h inverse of x. Okay, so I'm going to write h inverse of x equals to log base 5 x plus 2. And there is our statement. Of course, we should always go in and check and verify on MattDoesMath, because that's going to make sure that we've got everything correct. So I'm going to X out the last problem. Let's just go ahead and check some things out. So h of x, which is the original name, equals to 5x minus 2. 5 to the x minus 2. 5 to the x minus 2. Then I'm going to type in the inverse. And remember, we need to give it a different name because most doesn't like the inverse statement. And I'm going to type in function. I'm going to go to functions, go back to logarithm, put in a base 5, and then I'm going to put x plus 2. Oops. When I do that, I need to make sure that I'm finding the logarithm of the entire value of x minus 2 as we've written over here. Now let's come in. I've typed it in correctly. And we can look. It actually shows really nicely that it looks like they are reflections. So let's type in the line y equals x. And the purple h of x looks like a mirror image of the black g of x. And once again, we can do a composition of functions just to verify. So we can say h of g of x. Okay? And notice that that y equals x line glows, and that verifies for us that they are in fact inverses.